This is Team 11's Prototype 1 design video for the Software Engineering Group project. Our client is Dream Heritage CIC and our project is regarding the Beaurepaire Priory ruins. The aim of this project is to relay the cultural significance of the Beaurepaire site to the local community, emphasising the manor's valuable contribution to the region's history. The proposed system will provide an interactive mobile information hotspot for tourists to Beaurepaire Manor and should be able to operate as a digital companion for visitors. This should include a means for people to volunteer or provide donations. The client also wants us to provide them with a 3D model of the ruins. This must meet certain requirements that will be discussed later in the video. In this design video, we will cover the 4 major divisions of this project: the front end, the core functional system, the back end, and the 3D modelling task. For each of these sections, we will give an overview of what is required and what we are trying to achieve. Then, a technical discussion on what we have done so far, how we expect each section will be developed in the future, and the development approach to get there. Before beginning any programming on either of the prototypes, we first brainstormed our ideas and created a lo-fi model of our designs. These designs also extended to include plans for how to create the interactive map which could then be used to inform visitors of the structures of the house and the history of each room. Several design considerations in this process involve the layout of the application. For example, should the information be structured in a more visual format using tiles, or perhaps more as a scrolling single-page app? By drawing out our various design ideas, we could evaluate the pros and cons of each design and develop the best possible structure for our application. After careful consideration from the drawn designs, this is the final structure chosen for our initial prototype. This is a full-page screenshot and would normally be enlarged on the screen and then scrolled through. The various sections of the application are as seen above. Next, we will look into each of these sections in closer detail.
The requirements specification detail the user-facing desktop site to direct users to the mobile web app system when accessing it from a non-mobile device. This page presents a first draft design of the main desktop homepage. A bootstrap template has been used to ensure information is presented neatly and consistently, making the site as minimal and simple as possible for a potentially large age range of users. JavaScript and jQuery have been used to animate elements of the site and to provide users with tactile feedback as they navigate it. This design represents one way information about the system may be conveyed to the user. The use of font-awesome HTML icons ensure it's simplistic and visually attractive to a user, encouraging engagement and an interest in the system. The website will contain directions to the site, and should a user wish to use the mobile system, it will function as an assistive tour guide to those already at Beaurepaire Manor. Using an embedded Google Maps iframe, the user can explore the area around Beaurepaire. A Get Directions button is provided, which when clicked will lead the user to get Google Maps directions to the ruins. An encoded URL takes users directly to the Get Directions page of Google Maps, which is preloaded with the Beaurepaire Manor as destination. In the initial brief, Dream made it clear that throughout the system they would like users to be informed of volunteering and donation opportunities. Colour-coded HTML links also encourage users to visit the main Dream website or sign up for volunteering opportunities. The email link uses an HTML address tag to direct users immediately to compose an email to Dream. This image is a sample of what the interactive map on the mobile system may look like. This won't be the entire interface, but it's a design idea for manually exploring the manor without the use of location-based tracking. Each dot is a button that will trigger a CSS modal to appear. These modals are animated with jQuery to retain a responsive and clean user experience. This slide demonstrates a sample information card. The modal pop-up is an overlay, meaning users aren't directed away from the map, breaking the flow of the system. In the future, we aim to add additional information to these information cards, potentially tabs allowing users to view sketches of the manor in the past, 3D renderings of the site, or information about the room's use throughout different periods of history. The first development for the next prototype will be to detect whether a user is accessing the device via desktop or mobile, ensuring that if a user is viewing it through a desktop, the site recommends that the user views it on a mobile device instead. For the coming round of developments, we will also consider integrating the results from the 3D modelling into the mobile system, as well as perhaps using it to improve the quality of the interactive map. As mentioned previously, the interactive map cards may be developed to not only display information about each room, but sketches of it throughout history and potentially 3D models.
We had various options in our requirements specification for how to implement the core interactive functionality. We could have QR codes. These require infrastructure, which the client would prefer not to have. RFID, again, this requires infrastructure. Bluetooth low energy beacons can't interface with a web browser, so this isn't feasible. User given location, this is a great backup as it still achieves the goal. Now GPS is ideal, this is what we would want to have in place. The client envisions walking around with the web app and it shows different information depending on your location. So we began evaluating the required positional accuracy of this system. The minimum size of the rooms means we'd ideally have 1 meter of accuracy for this feature to work, which is possible if the GPS API provides frequent updates. We could take an average for instance. I created this GPS testing tool so we could see how accurate the GPS actually is in the area. It uses the geolocation API to get the user's latitude and longitude, then overlays it onto the Here Maps API. We went out and tested this tool. We met up with the client at the actual site of Beaurepaire. I got some scans of the site for Project 2, which will be discussed later in the video, and we got some results after testing the GPS quality using the tool. We found that the GPS accuracy was not good enough for accurately determining which room the user is in. Because of this, we have decided to design an interface without a reliance on gathering the user's current location. For future development, we have been brainstorming various options on where to go next. As demonstrated in the front-end section, we have currently implemented a map of the areas, which each have associated data. This can be improved on in the future by creating a system that incorporates a 3D model into the user interface. This will give us a higher fidelity for marking locations of interest at the site and hopefully make the web app more interesting. The client has shown interest in making a 3D model of what the ruins used to look like, which would work perfectly with this system as we could overlay the manor model onto the ruins.
Early in the project's development, we decided that implementing an administrative backend would be a key requirement in order to make the system adaptable and extendable without requiring technical knowledge. Initially, we looked at pure functionality of the backend and the actions it should be able to perform. Through this flowchart, a few key features became apparent. With such an emphasis on ease of management, we would need some kind of interface through which records could be edited. Also, we would need a reliable and easily editable way of storing the information such that it could be modified within this backend program. The first of these points gave rise to Sandman. Sandman is a backend administrative tool designed from the ground up to be tailored to Dream's needs. Firstly, we created the web pages through which administrators could interact with Sandman, including a dynamic login page. This page would be a secure method of accessing Sandman and thus the information cards. The next web page we made was the administrative portal, where the files could actually be edited, added and viewed. Executing the three options needed to be intuitive and simple, so we implemented pop-up web forms that allow for the addition of data by filling in the respective fields. Upon completing the form to add a new record, the information entered would be instantly propagated to the content management system and thus to the users of the web app. The same would occur for editing an existing record. The second requirement raised by the design flowchart was that a reliable way of storing information would be paramount to the function of the back end. To implement this, we are looking at a few different methods, of which there are two main classes, JSON and databases. JSON is a notation for storing data that allows for simple transfer between a backend and a web page, as well as class-based storage information. This would mean information could be stored in a well-organized, easily transmittable format that allows for grouping of information about identical locations. Databases are a more formal method of storing data such that it can be processed with ease as well as loaded as needed, while JSON can only be loaded altogether. A database is more complex to implement than storage as a JSON file, since it cannot innately be sent across a network and would require formatting beforehand. JSON storage provides a rapid way of delivering data but lacks the precision to access individual records, while a database would provide reliable and accessible storage but would be more difficult to implement and transmit.
For the 3D model part of the project, we have three objectives. Produce a 3D printed model. This is the objective that requires the least amount of accuracy in the model. Integration into the Project 1 web app. For this, the model needs to be the most accurate but more optimized as it will be running in a phone browser. Government guidelines. They want a 3D model that matches the scheduled monument consent criteria in case they want to make future site restorations and repairs. We received files from the client which I began converting into viewable images. The most useful files for making 3D models was the colour one for texturing and the digital elevation model, or DEM. The DEM holds height data for each pixel, perfect for creating a 3D model. However, all of this data is orthographic, so there is no data for the sides of any walls, only the tops. I used a program that scanned through each pixel of the DEM and converted its grayscale value into a vertex height. This produced a mesh of the Beaurepaire ruins. However, as you can see, there are large spikes that have formed. I also used a very high resolution grayscale image they provided to add some extra detail to the render of the 3D model. I converted it into a normal map where the RGB values of each pixel corresponds to an XYZ value, a vector. This can then be fed into a renderer to make the surface appear to have extra detail. This is perfect for Objective 2 as it could be used to make the in-browser render look better without much of a performance hit. I combined all of these different aspects to produce a better render of the model. This still had defects, however. No textures or vertices for the sides of any walls, and it still has the spikiness created from the DEM. During our visit to Beaurepaire, I took some augmented reality scans using Google's AR Core. The new scanned areas are shown here in white. I textured these new scans and loosely stitched them into the model, however a lot of work still needs to be done. In the future, we'd like to take more augmented reality scans of the site to improve the accuracy of the model. Ideally, we'd like to get a drone scan, as this would be much more detailed and achieve all of the 3 objectives perfectly. An agile approach will be taken for these, where multiple prototypes of the 3D model will be made. One prototype for the AR scans, another for the drone scans, and another one that's optimised for a phone, etc. Completing more of the objectives with each iteration.
Overall, we achieved a deep understanding of the project objectives and all the possible ways of implementing the project requirements. We decided that the planned web app will have a front end where general information and an interactive map will be shown. We also decided to implement a back end with user authentication so that the admin or user with privileges could log in to add, edit, or delete information. Finally, we explored the provided 3D data files and identified areas for future improvement.